Okay, critical phenomenon of gas or critical behavior of gas. Critical temperature Tc. It is defined as that temperature above which the gas cannot be liquefied, whatever may be the pressure applied. Or it is defined as the temperature above which no gas can be liquefied, whatever may be the pressure applied. Critical pressure, the minimum pressure required to liquefy the gas, is called critical pressure and represented by Pc. Critical volume, the volume occupied by 1 mole of gas at the critical temperature and critical pressure, is called the critical volume and represented by Vc. Critical point or critical constant, a gas or liquid at critical temperature, critical pressure, and critical volume is called critical point, and collectively uh, critical temperature Tc, critical pressure Pc, and critical volume Vc are called critical constant. Explanation of critical phenomena on the basis of isotope of carbon dioxide, pressure, volume at different temperature. A graph of pressure versus volume for carbon dioxide gas showing critical condition. We know that real gases tend to obey the ideal gas equation only at high temperature and low pressure. High temperature and low pressure, real gases tend to obey the ideal gas. That is, if temperature is decreased, that is, if temperature is decreased and pressure is increased. You remember, we know that real gas tend to obey the ideal gas equation only at high temperature and low pressure. If we reverse, that is, if the temperature is decreased and pressure is increased, then real gas deviate from ideal behavior and leads to the liquefaction of gas. And this plotted a graph of pressure P versus volume B at different temperature T of from okay, sorry. And this plotted a graph of pressure P versus volume B at different temperature T for carbon dioxide. Such a PV plot is called isotope. In Andy's experiment, the isotopes were drawn at a different temperature, 13.1 degree Celsius, 35.5 degrees Celsius, and 48.1 degrees Celsius. Let a gas has the volume and pressure corresponding to point A. When pressure is increased, the volume of gas is decreased up to the point B. Boyle's law. After the point B starts deviation from Boyle's and volume decreases rapidly when the gas condenses into liquid and liquefaction completes at point C. The pressure corresponding to the exerted by horizontal portion BC is the vapor pressure of the carbon dioxide at 13.1 degree Celsius. The PV curve or isotherm at 21.5 degree Celsius shows similar behavior but some remarkable conditions. With increase in temperature, the liquefaction of carbon dioxide gas takes place at higher pressure. The liquefaction of carbon dioxide starts at 13.1 degrees Celsius at point B, while that takes place at point F at 21.5 degrees Celsius. F is greater pressure region than B. Increase in temperature should be compensated by increase in pressure for liquefaction. The volume occupied by a given mass of saturated vapor at the initiation of condensation becomes smaller with rise in temperature and increases density. Volume of gas at F is lesser than the volume at B. The volume of liquid at the termination of condensation process becomes greater with rise in temperature. Example, volume of liquid at G is greater than C. The horizontal part of isotherm becomes smaller with rise in temperature. It consequence of point 1 and 2 mentioned above. The horizontal part isotherm becomes smaller with rise in temperature. The volume of liquid at termination of condensation process becomes greater with rise in temperature. The volume occupied by a given mass of the saturated vapor at the initiation of condensation becomes smaller with rise in temperature, increases density. Volume of gas at F is lesser than volume at B. With increase in temperature, liquefaction of carbon dioxide gas takes place higher pressure. The liquefaction of carbon dioxide starts at 13.1 degrees Celsius at point B. Okay, it's all about critical phenomenon of gas or critical behavior of gas. Thanks for watching and request you all like, comment, share and subscribe. Thank you for patience. That is now bye bye. See you again.